So after observing the stress and strain, that is the stress is force per unit area and the strain is change in length per unit original length, we are coming to the next point, that is elasticity. We have seen this term from previous स्टँडर्ड्स. म्हणजे काय की इलॅस्टिसिटी म्हणजे काय, एखादी बॉडी मी पुल केली आणि परत सोडली की ती परत काय करते, त्याच्या ओरिजिनल शेपला येते. सो व्हेन लोड इज अप्लाइड ऑन द मटेरियल इट गेट्स डिफॉर्म. म्हणजे मी एक रबर घेतला, थोडासा ओढला, इट गेट्स रिफॉर्म. अँड व्हेन द अप्लाइड लोड इज रिमूव्ह, त्याचा लोड काढून घेतो, द मटेरियल कम्स बॅक टू इट्स ओरिजिनल शेप अँड साईज. सेम थिंग तुम्ही जर यंग्स मॉड्यूलस गेल्या वर्षी चेक केला, मी एक रॉड घेतला आणि त्या रोडला थोडं फोर्स लावला, म्हणजे मी त्याला काहीतरी वेट लावलं, आणि after some time if that weight is removed, that rod comes to its original position. What it is, this is nothing but the elasticity. What it indicates, so material gets deformed whenever the load is applied, and whenever the load is removed, the material regains its original size and shape, and this term is known as elasticity. Here there are the two axes, that is one is stress on the y-axis and strain on the x-axis. So it is the graph of stress versus strain, and what the hook says that within elastic limit stress is proportional to strain. Within elastic limit म्हणजे काय मित्रांनो, जोपर्यंत ते मटेरियल जर लोड काढला तर ओरिजिनल पोझिशन येत असेल तर म्हणजे within elastic limit stress is directly proportional to strain, that is sigma is directly proportional to epsilon, and therefore sigma is equal to capital E into epsilon. What this capital E indicates, this is a constant, and this constant is known as Young's modulus. So again the thing is, then what is sigma? We have already seen stress is force per unit area, and what is epsilon? That is the delta, that is the change in length per unit original length. So I can say P by A is equal to E into bracket strain, that is change in length per unit original length. So what I can say, delta is equal to PL upon AE. So change in length can be given by PL. So listen here, what the problem is here, what they say, a rod 1 meter long and 20 mm into 20 mm in cross section is subjected to a pull of 10 kilonewton. Determine the stress in the rod. So first I draw here the rod. Suppose they are saying a rod having a cross section of 20 by 20, that means this is 20 by 20 cross section, and this rod is subjected to a pull of 10 kilonewton. Whenever we say this rod is subjected to a pull of 10 kilonewton, it might be fixed or you can show it on both the sides. Determine the stress in the rod. First thing we know that stress is equal to force per unit area. How much force is applied here, friends? So that is nothing but 10 kilonewton. But I should have to convert it into the Newton, so that will become 10 into 10 raised to 3 Newton. And here the second thing, what is the area? Area is 20 into 20. That means area is 20 into 20, that is nothing but 400, but that is mm square. So it is a 10 kilonewton upon 400 mm square. So what it will become? It will become 10 into 10 raised to 3 Newton upon 400 mm square. So it is nothing but 10 raised to 4. So I can say instead of that 10 raised to 4, I can write in this way. This is 400 Newton per mm square. This will be cancelled, 100 upon 4. That comes out to be 25. So the second thing, whenever I am saying this comes out to be 25, what it is? This is 25 Newton per mm square. Per Newton per mm square is what? That is megapascal. We have already seen. So I can say it is a 25 Newton per mm square, or it is a 25 MPa. What they say, calculate the safe axial load in tension for a steel rod of cross-sectional area 75 into 12 mm, 75 mm into 12 mm if allowable stress maximum allowable stress is 155 MPa. So what they have provided you, dear friends, here they have provided you the sigma, that is the max, sigma max, म्हणजे जास्तीत जास्त किती stress ते material घेऊ शकतं. What they say, it is nothing but 155 MPa, but I should have to know that this is nothing but 155, but MPa denotes it is a Newton per mm square. So I should have to take the area also in mm square. I calculate area. Area is equal to 75 mm into 12 mm. So that is equal to 900 mm square. I know that sigma is equal to P by A, but here I want to find out P. So P is equal to sigma into A. So what it is? We know that sigma is 155 and area is 900, but I write along with the units. So just check it. This is kilonewton. Kilonewton, yes, no, no, what it is, this is Newton per mm square and this is mm square. So this will get cancelled. 155 into 900. You should have to multiply this. Whenever you multiply, you will get 139,500 Newton. But I want to convert it into the kilonewton. If I say it should be converted into kilonewton. This will become 139.5 kilonewton. So the answer should be 139.5 kilonewton. Listen here. Find the required diameter of steel rod. Find the required diameter of steel rod that has to carry an axial pull of 40 kilonewton if the permissible stress is 150 MPa. Just note the observations carefully. What they say, find the required diameter. What should have to be calculated? Diameter, which is carrying an axial pull of 40 kilonewton. If the permissible stress sigma max is equal to 150 MPa. First thing I know that sigma is equal to P upon A. That means I can say it is a 150, but whenever I say 150, you are already knowing it is a Newton per mm square is equal to P. P is how much? P is 40 kilonewton. I will convert that into Newton, dear friends. So that is 40 into 10 raised to 3 upon area. What is the area of any circular rod? That is pi by 4 d square. So the thing is, I will transfer only d square on the opposite side. So what will happen? D square is equal to 40 into 10 raised to 3 will be as it is. Pi by 4, pi as it is, 4 comes to the numerator and 150 from this side will move on the opposite side in the denominator, that is 150. So if I want to find out the diameter, I will say D is equal to root of this 40 into 4, that is nothing but 160 into 10 raised to 3 upon pi into 150. Whenever you find out the root of this, you might get it is as 18.43, but I will request you just use the calculator and check it. Just listen. A steel rod 500 long and 20 into 10 in cross section is subjected to axial pull of 300 kilonewton. If the modulus of elasticity is 2 into 10 raised to 5 megapascal, calculate stress, strain and elongation. So I am just been checking here. Just we get the data from this. A steel rod of 500 long. So L is equal to 500 and cross sectional area. So area is equal to 20 into 10. So it is a 200 square. Pull is equal to 300 kilonewton, or you can say 300 into 10 raised to 3 Newton. Thereafter, the Young's modulus is given as 2 into 10 raised to 5 megapascal, but again I am writing in detail, it is a Newton per mm square. And now we should have to find out the stress. What is stress? Stress is force per unit area. What is force? Here it is a 300 into 10 raised to 3 upon area, that is 200. So if I observe, this will be 3 by 2, that is 1.5 into 10 raised to 3. 1.5 into 10 raised to 3. But the thing is, what is the unit of force? That is Newton. And what is the unit of area? That is mm square. So it is 1.5 into 10 raised to 3 Newton per mm square. Thereafter I am coming to the next point, that is strain. What is the strain? Strain is, we know that, what is the Young's modulus? Young's modulus E is equal to stress upon strain. So strain is equal to sigma upon E. What is sigma now? That is 1.5 into 10 raised to 3, that is Newton per mm square, upon E. It is 2 into 10 raised to 5 Newton per mm square. And the last one they have asked us delta L, but we already know PL upon A, change in length upon original length is the strain. So delta L is equal to PL upon AE. But in this case, what is the P? Again the same thing. P is 300 into 10 raised to 3 Newton. L 500 mm. Area 200 mm square. And Young's modulus is given as 2 into 10 raised to 5. You just calculate it and tell me the answer.